This video is going to look at how we use synthetic division. Now, if you have a polynomial function, you can use synthetic division if it's divided by x, if you can write it in the form of x minus a number. So, when you're dividing it by x minus a number to get the ball rolling, it's going to be x minus the number in the box. So if I'm going to divide this by x minus 4, then it's the actual 4 that's going to go in the box, not negative 4. Then what I need to have here are my coefficients for my polynomial p of x. And I can see that all powers of x are represented there. So my first coefficient is going to be 4, then negative 10, then negative 11, then 16. Then I skip a space and draw a line, and I get the ball rolling. 4 times the number in the box is 16, and then we add. And negative 10 plus 16 is 6. 6 times the number in the box is 24, and then we add. So negative 11 plus 24 is the same thing as 24 minus 11, so that's going to give me 13. 13 times the number in the box is 52, and then we add. Okay, so when I'm done, then I draw a line, which I like to do in a different color. And this number here is my remainder. And these numbers tell me the coefficients of the quotient. So I start at the bar, that's my constant, that's my coefficient for x, that's my coefficient for x squared. So if I'm asked, what's the quotient? What's the remainder? I'm able to answer those right now. The quotient is 4x squared plus 6x plus 13, and the remainder is 68. There's also another way you could be asked. You can write p, my polynomial p, as the divisor times the quotient plus the remainder. Now, what's the divisor? Well, the divisor is the thing that you divided by. So I divided by x minus 4. And the quotient, I've already figured that out. Then plus the remainder. So we should have plenty of ways to answer the web work. Let me come here to web work. So if we come to synthetic division review, problem number 1. Well, it's x, you're dividing by x minus 4, so 4 is going to go in the box. And this polynomial on the top is your polynomial p, and you should be able to get quotient and remainder. For this one, this is how they want you to write it. Figure out the quotient and the remainder. So x minus 4, 4 is going in the box. And then it will be divisor times quotient plus remainder. And they actually gave you the divisor. They just want quotient and remainder in there. Okay. But there is another way we can write this. If we divide p of x by what it was divided by, x minus 4, well, I can do that on the left-hand side. I just have to do it to every term on the right-hand side. And then I have some cancellation here. And so I'm left with my quotient, and then this fraction, and there's no reducing that fraction. It's an actual fraction. Okay. So that's another way the answer is asked for in web work. If we go on to problem 4, That's how they're going to want you to answer this problem in web work on that second way that I wrote it. Same for problem 5. Okay. Now, if we come back here, so if we come to this one, you might think, oh, wait a minute, you can't do synthetic division. It has to be written as x minus a number. Well, you're going to rewrite this. You can rewrite this as x minus -1, and it's always x minus the number in the box. So for this one, I'm going to put -1 in the box. Just let me give myself some more room. Now here, my polynomial, if I just wrote 1, 5, 1, 2, I would be wrong, because not every power of x is represented there. Your polynomial, what you actually have is 1 times x to the 5th, but there's not an x fourth term. There's not an x cubed term. Now I can write all of these numbers. I'll have 1, and then I have to put these 0 placements, and I have 2 of them here to put. Now I can set this up. 1 times the number in the box, then we add. -1 times the number in the box, then we add. 1 times the number in the box, then we add. 4 times the number in the box, then we add. And -3 times the number in the box, and then we add. So I'm done. And I can see now, this is my remainder. And what's my quotient going to be? My quotient is going to be, start at the bar. That's my constant. That's my coefficient for x, x squared, coefficient for x cubed, coefficient for x to the 4th. You keep going until you run out of numbers. So my quotient is going to be x to the 4th minus x cubed plus x squared plus 4x minus 3. And my remainder is going to be 5. I could write p of x as the divisor. What did you divide by? X plus 1 times the quotient plus the remainder. Or I could write it like this and divide each thing by x plus 1. So I have cancellation there, and I would have this form. Okay. So after seeing this, everyone should be able to do questions 1 through 5 in their web work. Okay. And we had this one. All right, so I'm just checking that the answers are correct. Now, how are you meant to answer something like this? Well, this is something new called the Remainder Theorem. Okay. But what I'm going to do now is I'm going to make some room. So, and oops, I need that. Okay, and I don't need that. Now, what the remainder theorem says is if you have a polynomial p of x and you use synthetic division, then P evaluated at the number in the box, so not P times, but P evaluated at the number in the box is equal to the remainder. And if you've already done the synthetic division, then you don't have to calculate this number correctly. So let's look at the remainder theorem for this first one here. The remainder theorem says that P evaluated at 4 is equal to 68. Now I can check that. I can do that directly. What is P evaluated at 4? Well, everywhere there's an X, you replace it with a 4. But if you've already done the synthetic division, why would you want to do it directly like this if you get it instantly? So 4 cubed is 64 times 4 is 256. Then minus 160 minus 44 and plus 16 we hope is 68. Okay, I'm trusting that it is. If I apply the remainder theorem to this one, the remainder theorem says P evaluated at the number in the box is equal to the remainder. And actually this one might not be too difficult to check directly. So if that's my P of X, what's P of -1? Well, it's going to be -1 to the 5th plus 5 times -1 squared plus -1 plus 2. -1 to an odd power is going to be -1. -1 squared is +1, so 5 times 1 is 5. So -1 plus 5 is 4, minus 1 is going to be 3, and 3 plus 2 is 5. Okay, but if I've already done this, P evaluated at the number in the box is equal to the remainder. So when you get to your web work, okay, here they want to know what is P evaluated at C, and C is equal to 2. They want you to find P evaluated at 2. Now remember, P evaluated at the number in the box is equal to the remainder. So to find this, you're going to set this up with synthetic division. And the number in the box is going to be 2. And then they'll want to know what the remainder is and what the quotient is. Okay. But once you've already found the remainder, then P evaluated at the number in the box is going to be the remainder. So these two answers are the same. So you don't have to go back and evaluate P of 2 directly. So what are they asking you to do on the next one? Same thing, using the remainder theorem. So what is P evaluated at C? They're wanting you to find P evaluated at -7. The remainder theorem says P evaluated at the number in the box is equal to the remainder. So you're going to set this up with synthetic division, but the number in the box is going to be -7. And so you'll get a quotient and you'll get a remainder that you put in here, and P evaluated at 7. These two things are going to be the same. Okay. So that concludes everything you need to know for your web work homework set on synthetic division review. And so I am actually going to stop the session.